You know, there's this invisible rule that's running the show for every single push, pull, and step you take. I mean, everything. It's one of those fundamental laws of the universe, and trust me, once you see it, you're gonna start seeing it everywhere. So let's dive right in.
I know, it sounds like a trick question, doesn't it? I mean, on one hand, you've got walking, the most basic thing we do, and on the other, a rocket launch, which is just peak human engineering. But the answer, and what they have in common, well, it unlocks one of the most powerful ideas in all of physics.
Okay, so let's start with something we all do, pretty much without thinking about it. Walking. The secret to how we even do it is the perfect place to start, because it's this universal law in action every single day.
So think about it. When you take a step, you plant your foot and you push. But which way are you pushing? You are actually pushing the entire planet Earth backward. Yeah, I know, it sounds absolutely nuts. But that backward push is the first half of the equation. It's what physicists call the action.
And here's where the magic happens. The Earth, in return, pushes back on your foot, and it does it with a force that's perfectly equal and in the exact opposite direction. That forward push from the ground, that's the reaction. And get this, it's what's actually moving you forward. So, in a way, you don't move yourself, the ground does. Wild, right? So this beautiful little dance of pushes, this symmetry, it wasn't just some random fluke someone noticed. Nope, it was actually laid out with incredible precision by the man himself, Sir Isaac Newton, in his third law of motion. This right here is probably one of the most famous sentences in all of science, and for a really good reason. It just perfectly nails the whole idea of interaction. Bottom line, nothing in the universe gets to push something without getting pushed back.
So these two forces, the push and the push back, we call that an action-reaction pair. And the key thing to remember is that it's always about an interaction between two different things. You know, your foot and the ground, a rocket and the gas it's shooting out.
Okay, now this is where it gets really interesting. Let's look at the details of this action-reaction pair. First, the forces are always equal in strength. Always. Second, they're always pointing in opposite directions. Third, they happen at the exact same instant. And finally, and this is super important, they always act on two different bodies. Your push is on the Earth's push is on you. They don't cancel each other out because they're not acting on the same thing.
Right, so once you get this rule, you really do start seeing it everywhere. Let's check out a couple more examples to see this law doing its thing. Okay, picture this. You're jumping from a small boat onto a dock. To get yourself moving forward, you have to push off the boat, right? You're pushing it backward with your feet, and because the boat's just floating there, you can actually see it scoot backward, away from you. That backward motion, that's the reaction to your forward jump. Classic example. Now this next one is a brilliant way to show the equal part of the law. If you take two of those spring scales, for measuring force, and hook them together, and then you pull, they will both show the exact same reading, every time. The force that scale A is pulling on scale B is perfectly, and I mean perfectly, matched by the force B is pulling back on A. It's just a perfect, measurable proof of the concept. And hey, this law isn't just about gentle pushes or walking around. It is the very principle behind some of the most powerful technologies we've ever built.
Take a gun, for example. When it's fired, there's this massive explosive force that launches the bullet forward at an insane speed. That's the action. But at that very same split second, an equal force pushes the gun backward, right into the shooter's shoulder. That backward kick, that's the reaction we call recoil.
And this brings us right back to that first question about the rocket. See, a lot of people think a rocket pushes against the air to go up, but that's not it at all. In fact, it works even better in the total vacuum of space where there's nothing to push against. So how does it work? Well, the rocket violently shoots hot gas downward. That's the action. And that stream of gas in turn pushes the rocket upward. That's the reaction. It's literally climbing into space by throwing pieces of itself in the opposite direction.
Okay, so this probably brings up a question that I bet is on your mind right now. It's a really good one. If the forces are always equal, why aren't the effects, why aren't they always equal? Right? This is the big puzzle. The law is very clear. The force pushing the gun back is the same as the force pushing the bullet forward. So, why does the gun just kind of nudge your shoulder while the bullet flies off at supersonic speed? The answer comes down to one simple four-letter word: mass. Let's break this down.
The force on both the gun and the bullet, it's exactly the same. But just look at the difference in mass. The gun is way, way heavier than that tiny little bullet. So because of that huge difference in mass, the same exact force causes a gigantic acceleration for the super light bullet, but only a tiny little bit of acceleration for the really heavy gun.
So here's the absolute crucial takeaway. Equal forces do not mean equal effects. The result, the acceleration, it all depends on the mass of the thing being pushed. It's why when you push backward on the Earth to walk, the Earth, with its unbelievable mass, basically doesn't move at all. But you, with your tiny mass in comparison, you get to accelerate forward.
So if you're going to remember just one thing from all of this, make it this. Forces never happen alone. They are never a one-way street. From the tiniest interaction between atoms to giant galaxies colliding, it's always a two-way deal. A push and a pushback. An action and a reaction. They always come in pairs.
Seriously, this law is just woven into the fabric of reality. When a bird flies, it's pushing air down so it can go up. When you're swimming, you're pushing water back so you can go forward. The entire universe is just this constant, perfectly balanced dance of pushes and pulls. So the only real question left is, now that you know the rule, where are you going to see it next?